Right. Welcome, everyone. We're going to get started to the Trees Around the Globe Student Research Campaign. We have a special webinar today. It's a GLOBE IVSS and International Virtual Student Symposia and Club de Ciencias Huechulafquen in Argentina. And we're going to be talking about an overview of the combination of trees, land cover, water quality, and mosquito habitats research they have been doing. And this is with Ana Prieto and her students from the Club de Ciencias Huechulafquen in Argentina. So first off, I wanted to give a special welcome to today's webinar to the community from the Globe Mission Mosquito. We have lots of participants from the Globe Mission Mosquito community who have joined this because of the discussion that the students are going to be talking about with their research that crosses everything from trees all the way through to mosquitoes. So we're super happy to have everyone here. We have several people, Cassie, Rusty, and Dorian from the Mission Mosquito team. And, let's roll on through. Our core campaign team is Dorian Janney from NASA Goddard, Peter Nelson from Oregon State University, Dr. Christopher Schumann from NASA Goddard and University of Maryland, Baltimore County, and Peter Falcon from the NASA Jet Propulsion Laboratory, and me from the NASA Wallops and Global Sciences Technology Incorporated. All right, so before we get into today's topic, what I want to mention here is, and I don't have a shareable for this because we're still working out some of the details because there's lots of things that we're putting together for this, but our July 2020 webinar, so next month's webinar, will be focusing on the baobab trees in South Africa and Madagascar. The featured talk will be from a curator of a botanical garden in South Africa, specifically George, South Africa. There may be participation from some students from GLOBE in Madagascar. We also have Peter Nelson will be doing a highlighting the Collect Earth, some high-res imagery of baobab tree locations. We do have a time set for this, but it's not on the GLOBE website yet because we're waiting for final details of everything. But it will be Wednesday, July 8th, 2020 at 10 a.m. Eastern Daylight Time, which is also 2:00 p.m. UTC. So notice it's not an afternoon one for, like we usually do, Eastern Daylight Time in the United States. It's not an afternoon one. We usually try that. But because we have a presenter from South Africa, we had to change it up. So it's a little earlier than normal. Usually by about 3 or 4 hours earlier than normal. But stay tuned to the website, and then also look through look for an email coming out in not too long from now with more specific information. All right, so let's talk about trees. Here's a tree fact. I started this last time, just a little tree fact here. The net cooling effect of a young, healthy tree is equivalent to 10 room-size air conditioners operating for 20 hours a day. Pretty crazy fact, isn't it? So this is why this is important. Planting trees that shade a house from sunlight during the hottest hours of the day help cool a house dramatically. In addition, trees planted along streets, sidewalks, and parking lots can help absorb light energy and evaporate water. So trees have so many different uses. They're so vital on our planet. They help keep our planet cool. They help pull that carbon dioxide out of the atmosphere through photosynthesis, converting it to oxygen. There's lots of things that trees help us with. So this is just one of those tree facts. Now, I want to show you this video. It's about 5 minutes or so, but before we get into everything, because we like to showcase a video about something, research related with trees and NASA related, other agencies or whatever. But this is called 40 Years of Forest Recovery. Since we're talking about trees, we have talked about the forest, a lot of the stuff that you all are doing has something to do with trees and forests. So, and this is timely because in the just like a week or so ago was the anniversary of the eruption of Mount St. Helens from back in 1980. So 40 years of forest recovery from all the way back to 1980. Here's a little a video that showcases what this is about. So let me start this for you.
My name is Sean Healy. I study forest dynamics. I study changes in carbon, changes in forest structure when they are disturbed, that is burned or cut down. I also study recovery. which is what we see a lot of following the eruption of Mount St. Helens. I visited it for the first time 20 years after. It was like a moonscape. A lot of it was still like a moonscape. You know, the pieces of pumice on the ground, no vegetation. It has been a place of extraordinary change over the last 40 years, from really beautiful old growth forest to a moonscape, and then back again to a lot of unbroken sort of 20-year-old forests, pretty high canopy cover, a lot of trees there now. From the fringes of the blast zone, you definitely see patterns of revegetation. They start slowly with a little bit of greening, but by the time you get to the end of the time series, it looks pretty dark green. And you see the same thing on the ground. You see a, you know, maybe not a 40-year-old forest, but something that looks 30 years old. And in this part of the country, trees are pretty tall after 30 years. What we're looking at is Mount St. Helens in southwestern Washington in 1973. The snow cover is what you see as white there, right in the middle of the mountain. It's surrounded by some dark, deep reddish forests, which is basically how this MSS imagery sees older growth forest. To the east of it, we see a lot of very active timber harvest. All of those patches of blue are recent clear cuts. Just to the north of the mountain there, you see a very large clear cut. That one happens to be about 2 square miles, which is really, really large by today's standards. And then Spirit Lake, just to the northeast of the volcano, you will see that the shape of that lake will change radically after the volcano erupts. Well, in this image, I mean, if you remember that large clear cut that I pointed out, you can see that it's starting to go from that bluish cast to having more red, which indicates, you know, recovery following harvest. And 6 years has passed, so you would definitely expect that in a very productive forest like this one. And it has been joined by a lot more clear cuts in that area, too. I have looked at a lot of Landsat scenes. This is the biggest change from one image to another that I can think of. Forests and everything else, many miles to the north, were just incinerated. The blast and the heat and the ash really leveled a lot. It looks from this image like Spirit Lake, just to the northeast of the volcano, is not there, but it is there. It's covered in logs. Most of the water in that lake got splashed up 600 feet or more and sort of dragged all of the trees that were on that wall down. Over the 40 years since the eruption, you know, we do see that recovery happens first in the places that didn't have, you know, that huge blast of heat and were not covered with many, many meters of ash or mud. In '84, the first thematic mapper, Landsat, was launched. So that really changes our ability to display this kind of image in something closer to true color. So it's much more intuitive. Green means green. So from this point forward, you can sort of visualize the encroaching greenness, which indicates, you know, the revegetating and reforesting areas after the eruption. Well, I'll also point out some of the remaining old growth forest that you can see in that very dark patch. In the MSS imagery, that was dark red. It's just much more intuitive to spot that kind of dark green when we can display it in true color. You can see in the early 90s, clear cuts starting to pop up. So basically it looks like it's going from green to some kind of brownish color. Even as the outer edge of these clear cuts are growing and filling in, the inner edges are greening up and turning green. And by the end of the time series, you know, they look pretty green, even though we just saw them get cut 30 years before that. So we have basically made a model that uses the imagery to predict what percent cover there is. Basically, how thick is the tree canopy here. And through the time series, you can see much of the blast zone going from red, which is 0 trees, to pretty green, which is, you know, pretty solid tree cover. And that's really solid documentation of, you know, the recovery of the forest in this area. You can also see, you know, its neighboring places go from green to red in the opposite direction. Obviously, there are harvests happening, and those are taking away forest canopy at the same time that recovery is adding forest canopy in the place that was affected by the eruption. The really unique part about the Landsat record is the fact that it goes back to the 70s. I can't imagine what it would be like to describe what this volcano did without having a time series of Landsat. We've got 8 years before the eruption and 40 years after the eruption. There is no other asset in the sky that can show us what Landsat does in terms of the effect of this eruption and also the effect of recovery following the eruption. It's just amazingly lucky that Landsat was up there and in its spot in the sky to watch this whole thing unfold. Let's hear it from Landsat.
So that really showed you just, just how important that Landsat series of satellites are. It's seen the entire 40 years of this forest recovery over Mount St. Helens. But I wanted to show you that because it's really cool. There'll be a link to that on the webinar page, once the archived webinar goes up, and we put all that information on there so you can take a look at that as well. So yeah, I just thought that was a great video to showcase, since we are talking trees. It's a trees campaign, and that's a very timely video due to the 40 years eruption of Mount St. Helens in 1980. All right, so quickly, let me run through these like I always do, the campaign metrics. We're gonna focus, in the middle here of the year 2, which is where we are right now. We hit over 10,000 tree height measurements during year 2 of the campaign from 4,672 global sites. We have over 4,000 land cover measurements and almost 4,000 green up, green down measurements. And the majority of those are coming from the European Phenology campaign. And we're going to be working with them, directly. And you're going to hear a lot about the European Phenology campaign for year 3, which begins in September 2020. And the full campaign, we have over 17,000 tree height measurements coming in from over 8,000 global sites, 11,367 land cover measurements, and just over 10,000 green up, green down measurements coming in for the length of the campaign from September 15, 2018 through the present. And here are what we have for May. We have over 1,000 tree height measurements, over 400 land cover measurements, and over 450 greening measurements just coming in for May. So, thank you all for that. And I always have to add this disclaimer in here because we are still in the middle of this COVID-19 pandemic, and I hope everyone is safe and healthy, and they stay that way. That's the priority. That's the most important thing you need to do. We can't go out and say, go out and take measurements for the GLOBE program. You have to do whatever you need to do at your own discretion, but we can't, advise and say, go out and do this, because your safety and your health is priority number 1. But there's a website on the bottom here. You can read all about GLOBE's response to the COVID-19 pandemic. It's a long URL. I probably should have put a shortened one there. But if you go to the GLOBE website and there's a scrolling banner on the top, I'm pretty sure that it's up there, and you can click on it from there on the globe.gov. All right, so I love this picture, Christopher, and I found it online on the I think it was UMBC site. But I'm going to turn it over to Dr. Christopher Schumann, and he's going to talk about trees in the news. Take it away, Christopher.
Hey, Brian, I'm pretty sure that picture is horrifically old. When I was still in building 22, the complete absence of gray is one dead giveaway there. At any rate. So the goal of this is just to bring in a brief news story, something, hopefully some of them will be more positive in the future, but I found this one because, of course, many of you out there are good cooks and may use olive oil in your favorite recipes. And so a pathogen which is threatening historic groves of olive trees in the Mediterranean is definitely not good news. So, and especially because of the long history of production of olives and olive oil in this region, you know, it sort of takes on a sort of historic importance, as well as just sort of being bad news for the farmers who take care of these groves and depend on them as a source of income in these challenging times. The disease has no known cure. I am not going to try to pronounce the name, but you can all practice, you know, there at the end of your Zoom screen. I think it's just amazing that everything that they have tried, if you read the story, the link at the top there, is just not having any effect. I'm also a fan of almonds and vineyards, and so the fact that it's damaging those in Spain is also not good news. And so I have great sympathy for the people who are being impacted by this deadly bacteria. It's kind of a parallel story to of course, the virus which is impacting all our lives. So it's just important to stay aware and to try not to spread, you know, these damaging pathogens to other olive growing regions, which fortunately there are some now far past their original historic range across the Mediterranean. So Argentina had to put you guys first, but also Chile, Mexico. Southern California is where I seem to find my extra virgin olive oil coming from. But pretty much all around the world except Antarctica. So it's, you know, good to diversify. I did not realize how broadly olives could be found until this story crossed my path. So one more slide, you can just kind of see what the impact is. Those barren branches are right in the foreground, are pretty clear sign of a tree that has lost the battle. The tree kind of directly behind it to the left is clearly badly damaged, and you have to get pretty far back to the left before you start to see a tree that looks almost normal. So this grove is clearly not doing well, and the people who depend on this for their livelihood are being seriously impacted. So just something to keep in mind when you're taking care of the trees in your area, that there are these challenges that can be particularly damaging and dangerous for people wherever they may be found. So thanks, Brian.
Right. Now it's back over to you, Christopher, with the imagery. But before you go from here, I want to also mention that if anybody has any questions, you know, make sure you put those in the chat. We will do Q&A towards the end of the webinar. There may be some in there right now. I'm sharing my screen right now so other people can check that out. Yeah, make sure you put some stuff in the chat. We have the students from Argentina, as well as educator Anna are here live, even though the presentation is pre-recorded, but they're going to be here live to answer any questions. Christopher?
Sure. Hey, so I too am very fond of Landsat, and although I could not find an MSS image to take us all the way back to the early 70s, I did find a nice pair of images from the 80s and earlier this year to just put you in the place where we're going to hear so much from the students and Anna later on today. I'm especially fond of this kind of mountainous terrain, which is kind of where the border between Chile and Argentina is running. And Junín de los Andes is a little bit out on the flats, as we'll see in the next slide, but the mountain peaks are covered with snow, just as we saw, and the glaciers may be largely gone from these peaks, even in the 1980s, but they carved beautiful valleys, which are full of blue water in these natural color images. And I should, Brian, if you would point to kind of the location of Junín de los Andes with your pointer, if you can. But at any rate, it's kind of in that curve of the river, which flows out of the big lake near the center of the image. Anna, I'll let you do the pronunciation when you do your presentation. But when I was working for Operation Icebridge out of, thank you for the note there. When I was working for Operation Icebridge, flying out of Punta Arenas down to Antarctica, we had some flights that were impacted by some eruptions of Chilean volcanoes. And I learned the story there that Chile has the volcanoes, but Argentina gets the ash. And the prevailing winds coming from west to east led to some flight delays for not just people on Operation Icebridge, but also my daughter, who was studying in La Plata when she went down to Ushuaia to see the glaciers in that area. So this is just an image pair, not a nice animation like we saw earlier, but I think you'll get the point when we go to the next slide, how much less snow and ice cover there is over time. And that's partly due to climate change, warming the atmosphere, producing less snow overall and more rain as a result, and also the fact that the snow doesn't last as long. So as Anna was able to show me, they know very well that the glaciers are in retreat here. But it's still a very beautiful area with the green forested slopes in the mountains, and the fact that all that topography causes rainfall to sort of stay on the Chilean side. You can see how much drier it is over on the Argentinian side, and it's clearly a challenging place to farm. Although I did notice that there was a good deal of what looked to be irrigated fields that have come up between the 80s and the early 2020 here image around Junín de los Andes. So people are finding a way to grow what they need and near where they need it. So that's good news for the city, which is also clearly growing over time. So it's just an illustration again of the sort of the power of Landsat and the kind of stories you can tell if you learn how to investigate remote sensing imagery. So I'll leave it there.
All right, thank you so much, Christopher. Yeah, that is just some amazing terrain for sure. All right, now I'm going to pass it over to Dorian Janney, and she's going to be talking about some champion trees in the region and among some other things. So Dorian, take it away.
All right, be my pleasure. I have the most fun because I get to go and do research on these areas that we're learning about. So I went in and I did a little research, first of all, to find out where the research by the students that we're going to be learning about was done. I may slaughter some of these words, so I will love it when we hear from Anna and our actual Argentinians, and they are using the correct pronunciation. But in any case, the Chimihuén River is in the northwest of the Patagonian province in Argentina, and its origin is in Lake, oh boy, Huechulafquen, and it passes by the city of Junín de los Andes. After a course of about 53 kilometers, it merges with the Ilumene River to form the Coloncura River. And if you look at the top, we're seeing over there where, and it's so neat the way that Argentina and Chile come together right there, and we can see those tall Ecuadorian Andes mountains there. And then we can go into the bottom picture and we get closer now to seeing the city where these students that are going to be presenting today live. And we're going to move to the next slide, and I'm going to take you and tell you about some of the trees that are there. I started by finding a national park that is close to their city. And in this national park, it has these absolutely amazing trees that are known as the Patagonian cypress trees. And apparently some of these they're the second oldest living tree species on Earth. And some of these can get so tall that they're kind of like those of us who live in the United States have been out to see the woods in California. Apparently, these cypress trees are simply amazing, kind of like that. So, boy, did this get me itching to head over to this part of Argentina and go to Patagonia. And if we look at the next slide, please. Another thing that they spoke about when I was doing the research was the fact that this area of the world is one of the prime fly fishing spots. And I've always absolutely adored watching and learning how to fly fish. So I'm going to have to come out and visit you there. This is another image of the Patagonian cypresses. And showing here that there's some of these trees that have grown as tall as 70 meters in height. Imagine using your tree height app and getting a hold of that, the height of that tree, and then up to 5 meters in the trunk diameter. You'd have to have one heck of a tape measure to get that. So sometimes it's given the name of the redwood of the South. And then I also put in there the species and the genus names for any of you who happen to be tree aficionados. But I did want to point one thing out that was pretty neat. Originally, the genus was named after the captain of the Beagle, which was the ship that went and had Darwin in it and did a lot of the early research into biodiversity. So I thought that was pretty neat. Then I'll tell you about 2 other trees on the next slide that are indigenous to this area. And in Juanín de los Andes, the city where the students are from, this Andean town in Argentina, has Patagonia's trout-filled river there and the gateway to those nearby lakes. And one of the 2 trees that it is very, very well known for, one of them is the monkey puzzle tree. Find out why it is called monkey puzzle. That was one of the things I meant to do, but I thought that was pretty neat. So the tree down at the bottom there, that one is the monkey puzzle tree. And if we go to the next slide, might be one more slide. Nope, I'm sorry about that. And the tree above it, that is the willow. And that is another tree that's very common in that area. And it's a special type of a willow that has adapted to be able to live in the ash and kind of with this amazing soil that's very, very fertile and rich because of the volcanic ash. So with that, take it away, Anna. Thank you, Brian.
All right, well, let me introduce today's featured webinar. And as I mentioned before, this is the main attraction, GLOBE IVSS and the Club de Ciencias Huechulafquen in Argentina, an overview of the combination of trees, land cover, water quality, and mosquito habitats. And Ana Prieto is a professor, Master of Education Sciences at the National University of Cumahu, coordinator of the Club de Ciencias Huechulafquen and program coordinator for GLOBE Argentina. That's a lot of stuff there, Ana. So what I'm going to do now is I'm going to say welcome to Anna and the students as part of the club. They are here and they will be here to answer questions after their presentation. And what we're going to do is I'm going to run the presentation now, and then it's pre-recorded. And then after that, I'm going to stop sharing my screen, and then we're going to go to question and answer for that. And then we will end the session today with Peter Nelson showing some online tools that he wants to talk about and some imagery that he wants to show you. So let me run this now. Actually, before that, Anna, do you have anything to say prior to this, or should I just run the video?
Okay. Hi, I am Anna. Sorry, the country coordinator from Argentina is Marta Kislan. I am
okay.
master trainer, but no country coordinator, teacher and other topics. My student, please, presenting Marianela, Juan, Lucio.
Well, my name is Marianela. I'm also Anna's daughter. And well, I will be presenting the project with my two partners that will present soon.
Hello, everybody. My name is Juan Wenker. I'm 17 years old. And well, I'm taking part in this presentation too. Thank you.
Thank you.
Hola, ¿qué tal? Soy Lucio. Bueno, pertenezco al Club de Ciencias. ¿Traducís?
Lucy doesn't speak much English, so I will be translating some of the things he says. He says that he's Lucio, of course, and he's also from our science club, and that he's 18 years old too. Thank you.
Thank you.
The presentation is recording, but internet is fluctuating.
Right. Anyone else?
In Patagonia. You hear me? The presentation is recording a video. For the internet is fluctuating in Patagonia is better, you can see good.
No. Okay. All right, let me go ahead and I will start the presentation now.
Okay.
Here we go.
We investigate mosquitoes in northern Patagonia, a cold and dry area. It is a transition area between the Andes Mountains and the Patagonian steppe. Winters are cold and wet, but summers are dry. Mosquitoes only breed in puddles near the river, jars and other debris that don't accumulate water in the summer because of the dry season. We are in a valley surrounded by mountains near the Cordillera de los Andes. Climatic characteristics of the region. Annual average temperature between 8 and 10 degrees. Annual average wind speed between 28 and 32 kilometers per hour. Annual average total rainfall between 1,000 and 1,100 millimeters. Research questions. What differences in water quality and macroinvertebrates are there between the Chimewin River and puddles near the river that have mosquito larvae? Why do some puddles have no mosquitoes? Will other aquatic species of macroinvertebrates and vertebrates be found in puddles with mosquitoes? Sampling sites in puddles near the Chimewin River, with mosquitoes and without mosquitoes. Materials and methods. Sampling period from January to March 2020. We use the GLOBE hydrosphere and biosphere protocols, the GLOBE observer, mosquito and land cover application. We sample in puddles and in the Chimewin River. We measure water quality, macroinvertebrates, mosquitoes and land cover. We put mosquito traps with yeast baits and bead shells. We locate them in natural and urban areas. To know altimetry, we use Google Earth Pro and Open Altimetry. We downloaded the satellite images from WorldView. For statistical analysis, we use Statistica, Test T, and Cluster Analysis. Here, you can see photos of environments, physical chemical analysis, and identification of mosquitoes and other freshwater macroinvertebrates. These are the traps that we place in natural environments, near puddles with mosquitoes and in urban environments.
Resultados preliminares. Solo encontramos mosquitos en pocos charcos. Los charcos con mosquitos son cerrados, sin conexión con el río. Solo en el charco 5 encontramos larvas de mosquitos y otros macroinvertebrados que podrían ser posibles depredadores. Lamentablemente no pudimos continuar investigándolo porque en Argentina se declaró la cuarentena por el coronavirus y fue imposible salir. Aquí pueden ver los charcos con mosquitos. En general solo hay mosquitos y anfípodos en densidades similares. Solo encontramos mosquitos del género Culex, fácilmente identificables por la forma del sifón que tienen. Aquí pueden ver larvas, pupas y adultos. Las pupas las mantuvimos en condiciones de laboratorio hasta que emergieron los adultos para poder fotografiarlos. No encontramos mosquitos en ninguna de las trampas. Junín de los Andes está en un valle rodeado de montañas. Esta característica hace que existan numerosas pendientes que facilitan el escurrimiento del agua, reduciendo el tiempo de duración de los charcos. En los tres cortes se muestran las pendientes en los charcos con mosquitos. A la derecha se muestra la pendiente del río Chimehuín, con el tramo de los muestreos con mosquitos. Los datos del satélite ICESat 2 muestran con mayor precisión que Google Earth Pro la altimetría de la zona. Lamentablemente no hay datos específicos para los sitios de muestreo, pero se puede tener una idea de las pendientes en el área. En el gráfico inferior muestran la altura de los árboles. En su mayoría miden entre 5 y 20 metros. Solo unos pocos llegan a 25 o 28 metros. Las imágenes de temperaturas muestran que a lo largo del periodo de muestreo la temperatura de superficie fue disminuyendo, tanto de día como de noche. Las lluvias fueron muy escasas durante todo el periodo de muestreo. El gráfico muestra los registros históricos de los meses de enero a abril. Se observa que la escasez de lluvias durante el verano se ha mantenido casi igual, con pocas variaciones desde el año 2001 a la fecha. El NDVI muestra el escaso crecimiento de la vegetación y cómo se va reduciendo de enero a marzo. El límite entre la estepa y el bosque. La humedad del suelo muestra un comportamiento similar. En el mes de febrero, el suroeste de Junín de los Andes hubo algunas lluvias. Por eso aumentó la humedad del suelo. En marzo se observa una marcada disminución de la humedad del suelo.
The land cover results around the river were only dominated by two types of MUC with similar percentages. The land cover in the puddle highlights the presence of trees with a high percentage of shade that reduces evaporation and changes in temperature. There is also a high percentage of herbaceous cover. The water quality results between the puddles and the river have similar values in temperature, pH, and nitrates. Very significant differences were found in dissolved oxygen. In the puddles, the oxygen is very low. There were also significant differences in turbidity and alkalinity, which is higher in puddles than in the river. Although the conductivity values are higher in puddles, these differences were not significant, possibly because they have a lot of variability. Puddle 2 had no mosquitoes. Water quality was analyzed only to compare quality with mosquito puddles. Puddle 5 was exceptional. It was the only one where we found other microinvertebrates, and the water quality was better than in other puddles. But there were fewer mosquitoes. The mosquito larvae was only found in puddles. A greater diversity of aquatic macroinvertebrates was found in the river. In Puddle 5, exceptionally, few mosquitoes and other microinvertebrates, mainly gastropods, were found. Okay, so in this slide, cluster analysis allows you to compare all sampling sites and all variables, setting similarities when grouped at a shorter distance forming a cluster, and differences when chaining distances are greater. In river sites 1, 5, and 2, and 3 form a cluster by similarities in water quality values, macroinvertebrate type, and land cover. Site 4 of the river is located after sewage discharge and has high levels of alkalinity and conductivity, low diversity of macroinvertebrates with predominance of gastropods. Puddle 2 had water connection to the river and had no mosquitoes. Its water quality is intermediate between the river and the puddles with mosquitoes. Puddle 5 with few mosquitoes was also atypical. It had no turbidity and alkalinity and conductivity values were lower than in the rest of the puddles with mosquitoes. In this puddle, there is the only one found to be more diverse in macroinvertebrates. In the analysis of variables, temperature, pH, dissolved oxygen, and nitrates have similarities. Alkalinity, turbidity, and conductivity have greater diversity of values. Macroinvertebrates have similarities to each other except for mosquitoes with a lot of variation between puddles. Land cover forms two clusters of similarities, one with the coverage of the puddles and the other one with the coverage of the river. The behavior of the canopy variable is different from the two groupings. So in conclusion, in the northern Patagonia region, the rains are concentrated in autumn and winter. In the spring, they begin to decline and the summer is dry. In the mosquito breeding season, the temperature rises and the soil moisture declines. The flow of the Chimui River decreases throughout the summer, reaching its minimums in the early autumn and leaving temporary puddles on its banks, which some are chosen by the females to lay their eggs. Mosquito puddles in general are characterized by being closed, ephemeral, with high turbidity, alkalinity, and conductivity. The dissolved oxygen content is very low. In puddles with a current of water, even if they are small, they do not have mosquitoes, and their alkalinity, turbidity, and conductivity are slightly lower than in mosquito puddles. The quality of the water in Chimui River is better than in the puddles. Macroinvertebrate diversity is greater in the river than in the puddles. In puddles with mosquito larvae, generally only amphipods were found. Female kulet mosquitoes would be choosing critical environments for other macroinvertebrates that could prey on them. It is recommended to carry out a greater number of investigations of the species and habitats of mosquitoes in Patagonia. Knowing the characteristics of habitats can be useful to design larval control systems and mitigate the effects of mosquito movements due to climate change to areas that are now extreme for their development. Thanks for your attention.
Great hashtag, researching at home.
We investigate mosquitoes.
All right, so I'm going to stop sharing right now. And I just want to say thank you so much for that presentation. That was wonderful. That really showed how complete the research was in that location. You know, it's not just looking at, you know, say tree height and be done with it. It's a comparison of all these things in one local environment, from mosquitoes to water quality to land cover, and then looking at where the trees are, you know, using open altimetry, looking at the ICESat data, looking at the trees from the ground, looking at them from space. So that was, you know, really an amazing presentation that really showed the complexity and completeness of that data. Does anybody have any questions here for the speakers who are with us? Please feel free to, if you need to, unmute yourself or put it in the chat.
Hey Brian, this is Peter. I did have something.
Right.
I was going to say I'm just very impressed that not only were they able to do such great research, but do it in a language that they're not familiar with and make this presentation. Not only was it very thorough and well organized, but they even thought to include captions. And I thought that was awesome to put captions in English. And as the presentation went on, I noticed that the three presenters were smiling there, and I thought they should be, because this is an awesome presentation. You guys did a great job.
Thanks, Peter.
Thank you, Peter.
Thank you,
There's
Peter.
a question in the chat from Peter Nelson. What should the next steps in your research be? If any of the students want to answer. Okay.
First, ¿cuál de nosotros
Sorry, the connection might be a little tough there.
¿Cuál de nosotros contesta? La pregunta es cuáles son los próximos pasos en nuestra investigación.
Bueno, ¿me traducís vos? Por ahora, continuar con imágenes satelitales hasta el próximo verano o hasta el momento en que podamos salir a muestrar al menos el hábitat.
With,
Lose somebody.
Yeah, we might be having a connection problem around Patagonia. Is any of the students still on? And Anna?
I have a problem with the connection is missing
Okay.
sometimes. The next step, continue in the characterizar habitat.
What we're going to say is that for now, because of the pandemic, we're going to be analyzing, I guess, satellite images. We are still connecting. Because
All right, we had a little bit of feedback there, but that's to be expected. There's a couple other questions here, and hopefully you might be able to answer those. From Amos, how did the NDVI affect the breeding of mosquitoes? And you may need to unmute yourself. If you feel more comfortable, you can put your answer in the chat. That's fine.
Dice, ¿cómo afectó el NDVI a la crianza de mosquitos?
Y que si hay más plantas y está verde, hay más humedad y más charcos.
Juan, ¿te animas a responder esa?
Dale, respóndelo.
¿O Lucio? Oh, bueno. What we are saying is that... Talk, Juan, talk.
Sorry. In response to the question about
yes, I guess. In response, we were saying that when there's more humidity, the more mosquitoes will grow, but I guess Juan's Wi-Fi is also not working very well. We have a lot of problems with Wi-Fi right now, but well. We were saying... well, we'll continue with the next question.
Okay, sure.
Because I forgot what I was saying.
Okay, from...
How did you decide on this research topic and these variables? I think it's the next one. From Peter.
Yeah, right before that is from Elias. He says, what kind of challenges did you face during your research?
¿Qué desafíos tomamos mientras investigábamos? ¿O qué desafíos surgieron?
Encontrar mosquitos el primero. Y después estudiar bien los hábitats, porque acá no sabemos qué pasa con los mosquitos. Ni siquiera qué especies hay.
Our first challenge was also obviously to find mosquitoes because there aren't many puddles. And we had to make a little investigation about the areas where mosquitoes live in our part of the river, because it's not usually common to find mosquitoes like in a great number. So, or in many stations, I guess it's like, because we don't find mosquito, for example, in winter, but in summer we have, but not that many. And these were some of the challenges we faced.
Thank you. And from Peter Falcon, how did you decide on this research topic and these variables? And that kind of goes to a combination of that question, and from Marina, what was the inspiration for this project? So that's kind of getting into the same question.
Más o menos, ¿qué nos inspiró a hacer el proyecto?
Sí, ver qué pasa, ver qué especies tenemos y que con el cambio climático hay casos de dengue en Neuquén. Digamos, se calienta un poco más, entonces ver qué pasa.
Well, our inspiration was because we have found out that around the time, like, I guess in 2018, started appearing dengue cases in the capital of our province, in Neuquén capital. And well, we were curious about which species can transmit dengue and another things and another diseases. And well, we were curious about it. And well, we decided to study also satellite images because we were working on satellite images when like with a project that we couldn't finish, which was about trees and forests. And also we decided that we can try to see maybe it will help our study around from the place of where the ponds were found.
Hey, Brian, I have a quick question.
Go ahead.
Just based on the Landsat, it seems like the town has really grown over the past 30 plus years.
Dice que la ciudad ha crecido.
The area of the town has expanded visibly in the Landsat images. And is there a significant growth in the population as well? Because that would make mosquito control more important for the growing population in the area, possibly with irrigation creating additional puddles during the summer months for the mosquitoes to grow in. So just wondering how those are all connected.
Dice que si más o menos se relaciona el hecho de que la ciudad ha crecido bastante y que eso también se puede observar por imágenes satelitales, y que si hay alguna relación entre los mosquitos y el crecimiento de la población, porque población humana, ¿no? Porque si ha crecido la población humana hay más mosquitos, o al revés, digamos. Que si quieren contestar los chicos estaría mejor.
Sí, yo contesto.
Dale.
Okay. We think that the mosquitoes has no relation with the overpopulation, or well, the growth of the city, because in our case our city is a small city, so there isn't a lot of garbage or trash, so there are no artificial habitats for the mosquitoes. So in our case, it has no relation.
Here in Greenbelt, we find that just people planting gardens can create habitat for mosquitoes. But we have a much more humid summer than you probably do. So that's kind of what the basis of my question is.
All right. I'm going back through. I don't see any other specific questions that we didn't cover, and everybody seemed lots of comments about how everyone loved your presentation. Thank you. Thank you everybody for saying that. It was a great presentation. And if there's here's one more from Lorene. How did you decide on the statistical analysis tools?
Yes, the statistical analysis, in general, I decide, but the students don't know a lot different methods for statistical analysis. Maybe I select for the better statistical analysis for the research. I explain to the student the statistical methods for applying this research. In general, I use in this moment, I use cluster analysis. In other moment, T or other tests for compare the means or compare the desviación standard.
Thank you, Anna, for that.
Thanks.
Noreen says, thank you for that. All right, so there's no less questions. Peter Nelson, are you ready to go?
Yes, I am, Brian.
All right, thank you, Peter. Sorry, we wanted to spend, take whatever you need to on this. That's fine. We have a captive audience, and everybody's really interested. It's been great webinars so far, and I will pass it over to you, Peter. Thank you so much.
Excellent, Brian. I really appreciate that. And I wanted to highlight for everybody this opportunity to explore one of the first global data sets that's out there, estimating forest canopy height. And I bring this up because this is one of the questions I have, is where are the actual trees around the world? And we can see from this data set that was put together from the laser system that was put up in space back in the 2000 time period, that actually was the beginning for what is now the ICESat 2 satellite that's up there. And so because of this instrument, it didn't actually collect the same type of data as the current ICESat 2 satellite. But it really does give us a first glimpse at some national estimates of tree height. And so I want to highlight this because this is a good place where you might be able to go explore and see what was created during that kind of first initial phase of data collection between 2004 and 2008. And with this, what I want to highlight is this is what scientists do with their data afterwards. And so after this project was completed, similar to our researchers who presented today, NASA asks you to actually put your data and make it accessible to other people. And so there are these what's known as distributed active archive centers, or also DAC. And when you go explore a DAC, you can actually find a lot of historical data sets and other research data sets that might help give you context for what you're seeing today. And so in this case, you can actually go down and you can read the particular paper that was used to create this data set, the way that they actually calculated estimates of tree height, and as well as the spatial coverage. So I encourage you to go explore how you actually document the data sets once you have created and finished a project similar to what our speakers did today. I really want to highlight that, in fact, there are two data sets that are available to you. One is a shapefile, which is a format that allows you to actually map this data and put it onto a geographic information system that allows you to do some other analysis, make maps, and that kind of thing. But there's also, importantly, a comma-separated file that allows you to actually, explore the attribute data without using a map. And as a result of that, you can go in and you can explore, the country of interest and find out how much forest area is in that country based off of a particular land cover methodology that we mentioned here. And importantly, how much hectares is available in relation to the ICESat measurements that were made. And so this is one way of starting to evaluate and understand and answer the question, what country around the world has the tallest trees and which country around the world has the shortest trees or may not have any trees whatsoever. And so you can actually go and explore this data set on your own, and I really encourage you to do that. And I'll highlight that earlier to bring this back to where we started hearing from Dr. Sean Healy, who is describing Mount St. Helens and the recovery that he measured there. This is actually a data set that he also put together as part of the carbon monitoring system that NASA and the Forest Service run together in conjunction to understand the world that's out there. So I just wanted to highlight this as a way of looking back between 2004 and 2008 and to understand the forest height that's out there. And the interesting thing is now we have ICESat 2 up there that's collecting data in a very similar fashion. And this allows us to do a comparison contrast. But importantly, I would like all of the researchers out there to consider and think about what type of information would we like to have in 10 years from now, right? What is the important part about the data that we need? How do we actually describe this in such a way that you can actually go back to these locations and do a comparison and see how have trees grown and how have they been impacted by the last 10 years of decisions? So we will provide this link out with this, and I'll do a little bit more data description about what I'm seeing in this data set. But I would really like people who are on this call and others who are interested to share with us what you find in this data set. Where is the tallest trees in the world based off of this initial estimation of global tree height? Share with us what you're finding and whether that's appropriate for or what you understand about your particular area. So with that, I will end my brief introduction to a really interesting and unique data set that was a predecessor to ICESat 2 data that you can find in the Open Altimetry website. So good luck on your data spelunking and comparison between this particular data set and the tree height estimates that you're finding in your area.
All right, thank you, Peter. Anybody have any questions for Peter?
Hey, Peter, this is Christopher. So because the lasers on ICESat versus ICESat 2 are so different in their sampling, for those of you that aren't quite as familiar, ICESat, the original mission, had a very large footprint, much more widely spaced than ICESat 2 does, which, because it's a photon counting instrument instead of a waveform collecting instrument, basically gets photon times back from each profile versus the broadly diffused waveforms from the original ICESat mission. So do you have any thoughts on how well those two different measurement techniques will play together, I guess?
Yeah, I think that there will be differences. You would expect to see some differences between that. And I would also anticipate to see some differences between those two different instruments in the way that they're measuring or trying to estimate that height of the structure of the trees in this case. But also the difference between what we're measuring on the ground and how we're measuring it. And for me, I think this is a really key piece of science. Right? How do we know what we're actually measuring is we're getting the right numbers, right? And depending on the instrument that you use, the size of the instrument that and what you're measuring might change over time. And so this is where this full documentation about the data set that you're using, the instruments that the instruments that you use to make those measurements, and importantly, the errors around that. What's the smallest thing you can measure? Millimeters or centimeters or meters? And what are the limitations? And the sample or the amount of data you could get back from this original LiDAR system was a lot less than what we're getting today. And so we would anticipate some differences between that. I'll also point out one of the big areas that you might find differences is in 10 years of tree growth. Every single tree that was measured by this particular LiDAR has grown. And the question is, how much has that grown, and how do you bring in that 10 years of growth into the differences in the instruments, as well as the actual making sure you're measuring the same exact tree. right? So this is, again, where that data documentation and maybe journaling, other pieces of information that can help scientists 10 years from now is a very important part of this process, because we expect instruments will get better. We'll be able to locate those trees a little bit better, but yet things will change. That tree may no longer be there in 10 years, or the trees that were measured by this instrument may no longer be there, right? So there's a lot of challenges as we start looking back into the past, and we have to start thinking about the instruments, the phenomena that we're actually measuring. And so that's where the only way to really know the differences or the challenges is to start investigating. So I do hope that people will take this data set and maybe compare it to the Open Altimetry website and see what they actually have. So that's a great research question, Chris. I really appreciate you bringing up the difference between the instruments and how that might affect our measurement.
I see a slightly different version of this in the tropical glaciers that I'm watching fade away, in that for many of them, the 30-meter pixels of the thematic mapper were fine back in the 80s and 90s. And as you get into the 2000s and the 2010s, the ice masses have shrunk so much that 30-meter pixels are actually too coarse to really get a good sense of how the ice has changed. Anna pointed this out to me on the local volcanoes across up the Chilean border area, where they actually have some pretty good documentation going back many, many decades, and as these ice masses have just shrunken away. And Landsat 10 is currently being designed and is likely to be substantially different than Landsat 9 that has yet to be launched. So this is the progress of technology and the commitment of resources to make things compatible with, but better in the long run.
Excellent, thank you. Anybody else have anything before we adjourn? I just want to say thank you to Anna and the students from the Club de Ciencias Huechulafquen in Argentina for the great presentation, really showcasing the, how, a lot of data in a smaller area can really matter in the sense that to knowing everything, possible about that environment. And it was put together so nicely. The students worked really well together, and with Anna. So, thank you so much for that presentation. And thank you for the folks from Mission Mosquito who came on the webinar today. We had, a lot of people here from all across the planet. I did a
Thank you very much.
Yep, did a quick count through. Thank you so much. Count through, and there were well over 10 countries who were represented here today. And as a reminder, this webinar will be, the recording will be archived. It will be put up once I get the info back from Zoom after this is over. I will probably most likely tomorrow put it up on the website. I will send out an email saying, hey, it's available right now to look at this. And then there's going to be links to things. Anna sent me a bunch of links yesterday, actually this morning, to go with the that were included in the presentation. Those are going to be going on the website as well, where the webinar recording will be. So we'll have lots of things that the links to Peter's the online with the ICESat information as well.
A little comment. In December, in my city, have a total solar eclipse in the next December. I hope the people come to look, and I am recording the event.
Excellent. Yep. Hope we can see that. All right. Thank you, everyone. I'm going to stop the recording now, and remember, look for information about the next webinar, and that'll be, as a reminder, July 8th, 2020, and it's going to be specific information will be coming out soon. So I'm going to start the recording right now.